Hi everyone, welcome to the first lecture of the control theory. I'm Tawhid Alizadeh, an assistant professor of robotics and mechatronics at Nazarbayev University, and I'll be guiding you through this course this semester. As you already know, this semester we will have a completely online delivery of the courses. So here, in the linear control theory with lab course, we will cover these topics in today's lecture. First, we will have a quick look at the syllabus. There we will see what are the main concepts that we are going to learn during this course, and a few more things regarding the organization of the course. And then we will have some real-life examples explaining the concept of the control theory. Then we will have a look at the automatic control. We will see the difference that we have for automatic control and the manual control there. And then we will have the explanation of the fields of the application. You will see that control theory is applied almost in every field. Then we will determine the elements, main elements of modern control systems, which will include the process and the core, and then the sensors and actuators, and finally the controller. During this course, we will focus mostly on the controllers, how to design them and how to analyze them. And then we will have some more examples at the end, and we'll see whether we really need the control after all. So as I already mentioned, I'm Tawhid Alizadeh. I'm an assistant professor of robotics and mechatronics. You can find the contact information over here. Whenever you need, you can contact me through my email as shown here. And we will also have some office hours, which will be in the online mode as well. So you can see the details over here. The main concepts that we are going to cover in this course start with the basics of the block diagram systems and the feedback systems. So you will learn at the beginning how a system could be shown in the form of a block diagram, and how a given block diagram system could be reorganized, could be simplified in order to obtain the one that you want to have. Then we will discuss about the feedback systems. We will see the open loop control systems and the closed loop control systems. You will find out the differences, and we will see why the feedback systems are more desirable for us in most of the cases. Afterwards, we will discuss the transient response of the systems. We will mostly focus on the step response of the systems indeed. And there we will see how different kind of systems behave in terms of the step response. Mostly the first order and second order systems will be considered here, and then we will see how the step response of a system changes when the location of the pole or zeros of the system change. Then we will have a look at the different type of controllers indeed, including the PID controllers. The basic concepts, practical realization, and tuning of the controllers will be considered. We will also analyze and design the controllers using different methods. The root locus techniques will be discussed. Initially, we will have the root locus analysis of the systems, and then root locus synthesis of the controllers. Then we will have a look at the frequency domain techniques, where we will indeed exploit the body diagram of the systems. We will analyze the systems by looking at the body diagram of the open loop system, including the controller. We will have an idea about the closed loop behavior of the system. And over there, we will learn how to design the controllers. And last but not least, we will have a look at the state space techniques. We will see how the systems could be shown, could be illustrated in the form of state space models, and how the controllers could be designed using this technique. So these are the main topics that will be covered during this course throughout the semester. The feedback control of dynamic systems will be our main textbook that will be used throughout the course. I guess you already have access to it through the Moodle system. The next course that could be used together with the first one is the Modern Control Engineering, written by Ogata. Regarding the grading for the course, over here in this table you can see the details. There will be about 4 or 5 quizzes. In total there will be 20% of the overall grade of the course coming from the quizzes. For the homework assignments, we will have around 5 as well. 10% will be coming in it from the homework assignments. There will be lab sessions which will be conducted online on your own. Indeed, you will work. I will explain it later. We will have around 11 lab sessions, and 15% of the total grade comes from the labs. And there will be 2 main exams, the midterm exam and the final exam. 20% for the midterm exam and 30% for the final exam. It's quite important to keep in mind that you should start studying since the beginning. You shouldn't wait until there is a quiz or there is an exam or there is a homework assignment. The learning process should be done in the continuous form. You shouldn't wait until things get accumulated and then you realize that you don't have enough time. If you have any problem in understanding any concept, you can contact me or the TAs of the course, as they will be announced later. Regarding the labs, we will do them using MATLAB. I guess you all have access to the MATLAB on your PCs. I will provide you the manuals, lab manuals, and you would need to go through them and complete the lab. Afterwards, you would need to submit a report in the form of a PDF file and also a short video recording of the lab of what you have done by explaining the different steps that you have taken. Again, I will provide you more details later regarding the labs. Alright, so here we have our first example of a control system. This is a manual control indeed, and all of us have experienced this. So assume that you are taking shower and there are 2 water knobs, one for the hot water and another one for the cold water. You have a desired temperature for the water, okay? Let's say around 25 degrees maybe. Even though you don't know the value for the desired temperature, but you have it somewhere in your mind. By turning the water knobs clockwise or counterclockwise, each one of them, you are controlling the pressure of the water, and at the same time you are controlling the temperature of the water. Here our focus is on the temperature. Okay, so if you open the cold water more than the hot water, the water gets colder, and if you open the hot water knob more than the cold water, the outcoming water from the shower will become hotter than the previous case. So with these 2, you are manually controlling it, and at the same time you are kind of measuring the temperature of the water coming out of the shower using your skin. So you have some sensors on your skin which gives you an idea of how hot the water coming from the shower is. Then you just compare this in your mind with the desired temperature that we already had here, and based on the difference that you see here, whether you need to make the water colder or warmer, you just turn the knobs and you do this a couple of times until you have the desired temperature for the water that comes out from the shower. And something else to consider here is that you should also adapt to the disturbances that may happen. Assume that you have set the water knobs such that you have the proper temperature for the water as desired. Then for some reason the heater, let's say, starts to work weaker, and then as a result the temperature of the hot water falls down. You need to readjust the knobs in order to get the same desired temperature for the button. Okay, so the control system works in spite of the disturbances. It should indeed work properly. The next example is regarding the case in which you are driving and you want to keep your position at a desired lateral displacement indeed. So you want to have a desired position for your vehicle within a lane. Let's say you want to stay in the middle of the lane. Depending on your initial position, you might need to turn the steering wheel towards the right or towards the left, such that your vehicle moves towards the right or left. Or if you are in a proper position, you just keep it straight. You don't turn the steering wheel. In this way, your vehicle will have a specific position with respect to the lanes. However, there might be some disturbances that happens, and it might be the curvature of the road. And when it happens, you obviously need to turn the steering wheel towards the right or towards the left. In this case, you are indeed using your eyes as the sensors. With the eyes, you just check the position of the car within the lane, and then depending on where the car is currently, which is measured by your eyes, and the desired lateral displacement that you have in your mind, you manipulate the steering wheel, and this results in the displacement of the car within the lane. So this is kind of the things that you do continuously, yeah? And it should also work in spite of the disturbances. So if a disturbance happens, which could be the curvature of the road in this case, you should adjust the steering wheel at that time in order to keep the position of the car in a desired way. So that's something that we do manually. But the focus of this course is on the automatic control systems. In the case of automatic control systems, the manual operation is replaced by some, in most of the cases, electronic components. Here you can see the main elements, let's say, or the structure of the automatic control system. Similar to the previous case, we will have the reference, which is shown as ROBT. Then there will be some control unit, embedded control unit that you could see over here. The embedded control unit receives the reference and the measurements from the process. Then, depending on the difference that there is between these two, it generates a manipulated input for the process, or UFT, the control signal, and then this will be applied to the process, and as a result, the output of the process will be adjusted. There could be some disturbances applying to the process as well. For the automatic control systems, there are two main terms to define. One is called the performance and the other one is called the robustness. When we talk about the performance, we are checking how to control the inputs U to the process automatically to make the output Y track the given reference R. While when we talk about the robustness, we exploit the measurements of the output in order to track the reference R in spite of disturbances. Okay, so we talking about the robustness, keep in mind that we are dealing with the disturbances, how the system behaves when the disturbance happens. So those were a couple of examples. In terms of the fields of the application of the control systems, you can find them in almost all fields, including the aeronautics and aerospaces, robotics, automotive industries, manufacturing, process control, power electronics, and so on and so forth. Basically, finding a field in which the control theory is not applied should be quite tough. It will be quite difficult to find that. Other than let's say the industries in which everything is done manually. Even over there, we have the manual control, but we don't have the automatic control. Yeah? If you consider the simple, let's say, farming, where you plant everything manually and you collect everything manually, obviously there is no automatic control system applied over there. But even in that case, for the modern farming systems, you could find lots of applications of the control systems. Alright, so here we have the main elements of the modern control systems shown. At the core, we have the process. The process is here. There are sensors to measure the output variable mostly, and then there will be analog to digital converter, A to D converters, which provides the signal for the control unit. The control unit will generate a signal to be applied to the process, but since it will be in the form of a digital signal, it needs to be converted to the analog signal, so D to A converters will be used, and then the actuators will receive this signal. So this is indeed the overall view of the main elements of the modern control systems. Regarding the process, we usually, when we want to design a controller, we need to have the model. A model of the system will be used in order to analyze the system and in order to design a proper controller for that. So actually we want to know the dynamic effect of U, which is the input to the process, on the Y, which is the output of the process. And for that we need to have a model of the process. We can obtain the model of the process using some physical principles which govern the system. Or if it's not possible or difficult to do, we can also use the identification techniques. But throughout this course, we will assume that we have the model, or obtaining the model will be quite simple, let's say, referring to some physical principles. In the continuous time mode, the model could be given in the form of differential and algebraic equations. You can see over here that x dot of t is a function of x and u, where x is the state of the system, y is the output of the system, and u is the input to the system. We will talk more about the state space representation of the systems later, but over here you can see how the model of a system is provided in this form as the differential and algebraic equations. We will also learn how to convert this into the transfer functions. Some concepts related to this already have been covered in the system dynamics course. So if you don't remember them, you better have a second look at the content of that course. Concepts such as transfer function, state space, stability, reachability, and observability. Whenever needed during this course, we will also refresh indeed your knowledge in those terms. In terms of the sensors and actuators, we will not, let's say, deal with them a lot in this course, but you should keep in mind that with the sensors, we convert some physical quantity to electrical signal most of the time. We can sense the temperature, pressure, flow, level, velocity, position, and so on and so forth, and there are sensors for these purposes. On the other hand, actuators are some elements which convert electrical signals into some action on the system. As an example, we have the electrical motors, pumps, valves, and heaters, but there are more actuators and more sensors than listed over here in this slide. In terms of the controller, it could be implemented as an analog circuit or a digital circuit or as a program in a given programming language. In the case of analog control systems, the controller itself is a continuous time dynamical system. So we will indeed design the controller, and then the controller could be implemented in the form of a analog system, and it itself is a continuous time dynamical system in it. Yeah? In the digital control systems, on the other hand, the control law is executed at fixed time instance with a fixed sampling time. So let's say every 1 millisecond. At each sampling interval, then the digital controller needs to read the measurements or the inputs. It runs a control algorithm and it generates some signals to be sent to the actuators. Here we have some more examples. You can consider the cruise control system of a car. For most of the modern cars, we have this option available, the cruise control. The modern cars are equipped with lots of sensors and actuators. The idea of the cruise control is to keep the speed of the car in a given amount. So you determine the desired speed. You can do it with some control manually, let's say. You can increase or decrease the desired speed with some knobs. And then there is the electronic control unit which receives this, and at the same time it receives the measurements in terms of the speed and position of the car. Then it compares the desired speed with the current speed, and it generates a proper engine torque, or it applies some signal to the brakes in order to increase or decrease the current speed of the car until the current speed reaches the desired speed. And the system works even if there are some disturbances, such as the road slope. When there is a road slope, then the control unit will change the applied torque or the signal that is applied to the brake such that the speed of the car remains at the same value. So this is something that is done by the automatic control unit, and you don't need to do it manually, otherwise you have to control the pressing of the gas or the brake pedals. Another example is the Segway human transporter, which is quite common these days. You can find them in many places, especially at the airports, for example. The main idea here is in terms of the balancing or self-balancing. And this should be done continuously. So we have the dynamic stabilization problem over here. This enables the Segway human transporter to work seamlessly with the body's movement. So you stay on the Segway, you move your body towards the front or back, and based on this, the sensors which are given or which are embedded into this system, such as gyroscopes and the tilt sensors, they will monitor the user's center of gravity. So whether you lean forward or backward, your center of gravity will change, and this will be measured at about 100 times a second. And then based on this, the system will move the Segway forward or backward. So you will control the movement of the Segway by leaning forward or backward. And this will be, the control thing will be done automatically. And finally, you might think whether we need the control or not. You can have a look at this story that we have here. It's regarding the A-class mini cars of Mercedes-Benz. The Mercedes called around 3,000 brand new A-class mini cars in 1997 in order to correct the stability problems revealed in Scandinavian tests. So basically they tested the car and the car failed to pass the test. It was regarding the moose test, and it was simulating a sudden swerve to avoid the moose on the road. And since the car failed that, they called all 3,000 cars, and they indeed solved the problem by introducing the electronic stability program, or ESP. you can assume how much money they have spent on this, but anyways, the control system introduced here solved a huge problem. So you can see how useful an automatic control system could be. All right, so that's all for this introductory lecture. In the next lecture, we will start to study the control systems in more details.